I decided to throw together a map to show you guys when you use particular types of calculation styles when you're working with titrations. There are two places where you would want to use ice tables, and the first one is at the very starting point when you have just your weak acid or your weak base in water. Those are your reactants. The other place is at the equivalence point. By this time, you've converted all of your analyte to its conjugate species, that conjugate acid or base. So now you have that weak acid or base interacting with water. Before you start your calculation, remember to adjust the molarity by calculating the total solution volume. At the midpoint, the pH of the solution equals the pKa of the analyte, and this is because of the Henderson-Hasselbach equation. We can also divide this map into two broad zones. You can see this red line going straight through the equivalence point. When you are to the left of that line, you are in the buffer zone. Because you are between the starting point and the equivalence point, you've converted some of your analyte to its conjugate species. You've made a buffer solution. So you should do stoichiometry to determine the ratio of the conjugate acid-base pair, and then you can use the Henderson-Hasselbach equation. If you have passed the equivalence point and you've gone to the right side of this graph, you are in the over-titration zone. You have added excess strong acid or base, so you should do stoichiometry to figure out how much of that acid or base is in excess. You can calculate the molarity of that strong acid or base with the total solution volume, and then you can use the negative log to calculate the pH. So there you go. Now you have this great map. Use it, and I will see you guys in class.